This is our project is locally hosted food recommendation multi-agent system. Uh, the system will accept a natural language food request from the user and extracts the dietary preferences, filters a local meal data sets, and evaluates nutrition stability, and finally generate a ranked food recommendations. The system runs fully locally using Ollama with 3.2 model, so it does not require paid cloud APIs. And also we use multi-agent workflow with 4 agents at the preferences analyzer, the menu fetcher, nutrition analyzer, and recommendation and report agent. Uh, this is our system architecture diagram. The next we are moving on to the system. This is my individual contribution. Is agent 1, the preferences analyze agent. This agent is responsible for understanding the user's natural language food request and converting it into structured JSON preferences. And the extracted fields are diet, calorie limit, excluded ingredients or allergies, and cuisines. And examples FE type like this. I want vegan food under 500 calories. Then it will run the system. In here, the request will be sent to the backend. System will be getting the recommendations like this. And if we are focus on the request, this is the request that we are sending to the agent. That means the diet type it is vegan, then calorie limit is 500, exclude nuts, and cuisine is none. The cuisine means or Indian or Mexican likewise. This is the request that's sent to the backend. And also when we are focusing on our implementations, here this is my preferences analyzer. Use system prompts to instruct the local Ollama model to return only valid JSONs. The agent does not directly trust raw LLM input. After extraction, the result is passed through the validation before being written to the shared states. Also, when we are focusing on tools, this tools that we are used. In here, I have used preferences validation tool.
After the preferences analyzer agent finishes, the menu agent starts working as the second component in our multi-agent food recommendation system. It receives the structured preferences and connects them with our meal dataset. Using Ollama 3.2, the menu agent normalizes and validates those preferences so the filtering process is clear and consistent. Then our custom filter tool filter meals based on extracted references. This helps the system select only most relevant meals from the dataset. If no meals are found, the agent uses a fallback mechanism to relax some filtering while still keeping the user's main idea. Finally, the menu agent creates a list of suitable candidates, meals, and passes them to the nutrition analyzer agent.
Now I am demonstrating about the nutrition analysis agent. It checks each meal to see if it matches to user's diet rules and removes the ones that they don't. In the UI, when I add a submit a preference like vegan under the 500 calories, no nuts, this section shows the nutrition analysis summary for that relevant preference. And as for the inputs, I get the candidate meals from the manufacturer agent, and also the outputs of my nutrition analysis agent are the meals that analyzed and also accepted and rejected meals from that analyzed part. And this agent uses mainly tools to development. The first one is that Bachelor that which we can use to identify score for all meals, and the other one is the compute headset to uh, detect the nutrition warnings, and that's all about the nutrition analysis agent.
My agent is recommendation and reporting agent, which is the final stage of the FoodMind food recommendation system. As you can see, it is built and convert the analysis mail data into clear final output for the user. So when we talk about it, my agent received two main input from the shared food state, the user preference and the scored meal list from the nutrition analysis agent. It doesn't invent new meal or change nutrition value. So the key functionality of my agents are ranking, selecting, explaining and reporting. First, it ranked meal based on the final score. Then it selected top recommendations such as best 5 meal. It's also add ranking labels like best match, runner up, third place, as you can see like this. So for each meal, my agents show the meal name, score, calories, protein value, health category and recommendation reason. Finally, it saved the output as markdown report, JSON result and trace log as you can see.